Hello Year 10. Right, okay, so you've got a little recap quiz to have a go at first. So pause the video and have a go at the questions. You just need to write the answers, you don't need to write a big long sentence. But don't go just straight to the answers, actually have a try at answering the questions, okay? It's all related to what we're going on to next, okay? So these are your answers, okay? So thinking about changes of state, and thinking about the periodic table and the position particularly of carbon and hydrogen, okay? Because carbon and hydrogen are very specific to this topic that we're going to be studying now. Okay, so in terms of what we're thinking about, okay, this black liquid here is crude oil. This little animation is showing that this guy's shirt is resistant to stains, even icky stuff like crude oil, okay, because crude oil is a very thick, treacly, sticky liquid, okay, so that's what you'll see when it comes out of the ground. So we need to think about what crude oil actually is, okay, where it comes from, what it's made of. It's actually a mixture of different chemicals. It's not just one liquid. When you see it coming out of the ground, it's that black, thick liquid, but it's actually made up of a mixture of other compounds, okay, all mixed together. We need to think about how they are similar and how they are different, okay, so it's all based around really crude oil, this topic that we are doing now. Okay, so crude oil is a fossil fuel, so it was made millions of years ago. Okay, it's very, very important because it's so valuable in terms of what we use it for. Okay, because it contains lots of other compounds. We separate it out using a method called fractional distillation, which I'll talk to you about later on in the week. Okay, so we use it for lots and lots of different things. Countries that have lots of crude oil are often very, very rich because it's so valuable in terms of all its different uses. So the most obvious ones are that we use it for making petrol and diesel, which we use in transport, but it's also used for airplane fuel. It's also used for boat fuel. We use it for heating. Okay, so some homes will use, or some power stations will use compounds from crude oil. We use it for generating electricity, okay, but then the other use of crude oil is in the petrochemical industry, okay, so petrochemicals are basically compounds that we get from crude oil, and we use it to make lots and lots of plastics, okay, so a lot of our plastics and dyes and materials are all coming from crude oil, okay, so it's a hugely important resource. Okay, but it is finite, it is non-renewable, okay, because we're using it so quickly, it's taken so long for it to be made that we can't replace it. Okay, so just in terms of where it comes from, it's found under the ground, okay, so we've got lots of oil rigs around the North Sea, around the north of Scotland, that will extract it from under the ground, under the seabed, okay, but these other two, the one that's turning round there, that is actually extracting oil from land, okay. Now, when it's extracted from land, it tells you that the area used to be covered by ocean, okay, because crude oil has been made from sea creatures, okay, so there has to at some point have been a sea covering these areas that are now on land, okay, so they will drill down into the land or into the seabed, and they will extract the oil out, and then it either gets piped or tankered to wherever it's needed, okay, so this just gives a quick introduction as to how that it's made. Fish and sea creatures, and usually it's very, very tiny sea creatures like microplankton, so microscopic plants, microscopic animals. They were all living in the sea, they still are living in the sea. They would die and they'd sink to the bottom of the ocean, where there's no oxygen for them to decompose, but they get buried in all the sediments, so all the sand and the silt and the mud and everything else, they get buried and buried and buried, which pushes them further into the earth, and also by pressurising it and compressing it, it makes it hot, and it's this heat and pressure that turns these dead sea creatures into oil, okay. Now the third picture shows how it collects, so you get these dead sea creatures turning into oil, and that will begin to rise up, okay. Now you've got the word porous there. Porous means that liquids can travel through it. So you've got underneath the sea creatures being changed into oil. it will rise up through that porous sediment, so it can pass through, a bit like a sponge, it can pass through that porous sediment and rise up. It can't get through the non-porous sediment, so the non-porous rocks stop it, and then you get a build-up of this crude oil underneath the non-porous rock, and that's where they would put their oil drills. Okay, so the last picture, it shows that they would put the oil drill on top of that deposit, drill down into the ground, and then they suck it out. Okay, so that's how it's formed. So again, like I said, it's lots of different compounds. It's formed through remains of plants and animals, mainly these tiny plankton, but it was formed millions of years ago, and we're using it much too quickly. Okay, so it is a finite resource. Now, oops, let me just restart the little animation. So you've got your idea there. Your sea creatures, they die, fall to the seabed, they don't get broken down, they don't get decomposed, so they get buried within the sediments, but that pressure and heat will turn their remains into oil over millions and millions of years. Right, okay, so, oops, oh, no, I can't do that bit. Right, so all the different compounds that crude oil contains are made from hydrogen atoms and carbon atoms. So you've got a little picture there. They're all slightly different lengths. Okay, so all the different compounds are slightly different lengths, but they're only made from hydrogen and carbon atoms. Okay, and they are called hydrocarbons. So the name hydrocarbon gives you a clue as to what they are made from. Only hydrogen, hence the hydro bit, and carbon. Okay, now the carbon will form different length chains. So in this case, I've got 1, 2, 3, 4, 5, 6, 7 carbons in a chain. Okay, this one is a much smaller chain. It's only got 2 carbons in it. So they're all different lengths, which makes them behave differently. But they are all hydrocarbons because they're only made from hydrogen and carbon atoms. Okay, now, in terms of the examples of these, there is a system of naming them. Okay, so the first hydrocarbon is called methane. Now we're going to concentrate on the alkanes, this group of hydrocarbons. So they all end in ANE. Okay, so all of these end in ANE, the ones we are going to concentrate on. We've also got another family which are called the alkenes. So you will notice that this methane ends ANE and propene ends ENE. So methane is an example of an alkane family, and propene is a member of an alkene family. Okay, but we're only concentrating on the alkanes for now. So methane, which is the gas that we burn at school, okay, in the gas taps, has got 1 carbon and 4 hydrogens, and that 4 is important, okay, because carbon, if you look at carbon in the periodic table, it's in group 4, and that means that it can form 4 bonds. Okay, so carbon can form 4 bonds, and it does that by sharing electrons, so it forms covalent bonds. Okay, hydrogen each needs to form 1 bond, right? So what will happen is that on each of these bonds around the carbon, okay, I will have a hydrogen. So I've got 1 carbon and 1, 2, 3, 4 hydrogens. So like we've just said before, that would be methane. 1 carbon, 4 hydrogens. Okay, now if I've got 2 carbons, so if I've got a 2 carbon chain, and this would be called ethane, okay, I'll give you a way to remember this later. One of the bonds, each of them has got 4, but one of them they are sharing between them. Okay, so this time, because one of the bonds is being shared by the carbons, I can only have 1, 2, 3, 4, 5, 6 carbons, okay, 6 hydrogens joined to this chain. So you have 2 across the top, 2 across the bottom, and then 2 on either end. Okay, so this would be ethane, because one of those bonds is shared between the 2 carbons. Okay, so in this case, I've got C2, because there's 2 carbons, and H6, because I have 2 above, 2 below, 2 on the ends. Okay, so it would be CH6. Now, there is a pattern to how this works, okay? So each time you add a carbon atom to the end, okay, so if I was going to add a carbon on here, you effectively add the carbon and 2 hydrogens, okay? So there is a general formula, and don't freak out because it looks weird, of Cn. So N is just the number of carbon atoms. So in this case I've got C4. And then the hydrogens, for each of my chain, I've got one above, one below. So for each carbon, I've got 2 hydrogens. So if I've got 4 carbons, then I'm going to have 8 hydrogens, which is 2 lots of 4. Okay, so if I've got 6 carbons, so my N is 6, this would be 12. Okay, now we have to remember the 2 on the ends. So I've got one on top, one below, and then the 2 on the ends. So that gives me 2n plus 2. Now this general formula helps you to basically figure out what's in any hydrocarbon at all. Okay, so if it's C, just one C, the N is 1, so it would be 2 lots of 1 plus 2, so CH4 like we've just looked at. And you're going to practice some of these in a second, okay? So this is the overall general formula, okay? Now, I'm going to ignore that for the time being because we don't need to worry about that. I think there's 4 that you need to know, okay? So you need to know the first 4 alkanes. You've got methane, ethane, propane and butane, okay? So methane has got 1 carbon, ethane has got 2, propane has got 3 and butane has got 4. And the way to remember that is monkeys eat purple bananas, okay? Monkeys, M for methane, eat, E for ethane, purple, P for propane and bananas, B for butane, okay? So that is monkeys eat purple bananas, 1 carbon, 2 carbons, 3 carbons, 4 carbons, okay? Now this table goes through all of them, so there are more than that. And you'll notice that it shares some letters with like some shapes that you've probably done in maths. So like 5 carbons is pentane, like you've got a pentagon. Hexane is 6 because like hexagon, okay? So we only need to remember the first 4. So methane, ethane, propane, butane. Those are the ones we need to know. Monkeys eat purple bananas, but these are the others. Now, what you're going to do is you're going to draw me out this table. No, you're not. I'm going to give you another sheet to do. Okay, but it'll involve a similar idea. So what you're going to do is for each of these, you're going to think about what it looks like. Okay, when I say what it looks like, I mean this diagram here. Okay, so this diagram on the left. So this one would be 1 carbon, 2 carbons. So it's not monkeys, it's eat. Okay, so this would be ethane. Right, you need to draw the formula, or draw the diagram like this, the displayed formula, and then you're going to write it as a chemical formula, okay? So in this case, you've got methane, which is CH4, and it's drawn like this. Ethane, remember, monkeys eat purple bananas, is C2H6, so you're going to draw it out, okay? Propane is C3H8. Draw that out, it's just 3 carbons, okay? Now it doesn't matter, I know we only need to know these 4, but it doesn't matter how many carbons you have. You could have, I don't know, C100, okay? C100 would be H, 2 lots of 100 plus 2. So it would be C100H202. Okay, if it was C50, it would be C50H102. Okay, so it doesn't matter, even if you get some quite scary ones with some quite big numbers, right, you still do it in exactly the same way. Okay, so there's a sheet on class charts for you to practice in terms of what I've talked about, what hydrocarbons are, and drawing the formula, or writing the formula, and drawing the displayed formula for some alkanes. Okay, and then you can upload it back to class charts, or you can email it to me. Okay, so that's your task for today, the sheet that is on class charts.